This is Mr. Martin. This video continues section 9.7 on graphing polar equations. So let's take a look at another example. Let's look at the graph of r is equal to 3 cosine 2 theta. So we know that this is an equation in the form r equals a cosine n theta, which is a rose, and since n is equal to 2, we're going to have 4 petals. And we also know that since it's a cosine, these 4 petals are going to be on our axes, so let's keep that in mind when we're graphing it. Let's go ahead and test for symmetry. So for the polar axis, I'm going to replace theta with the opposite of theta, so I have 3 cosine 2 times negative theta, which is 3 cosine negative 2 theta. And using our even odd identities, we know that cosine of a negative angle is the same as the cosine of a positive angle. So that's the same as the cosine of 2 theta. So that checks. So it has polar axis symmetry. Now let's check for theta equals pi over 2 symmetry. So we're going to replace theta with pi minus theta. Let's go ahead and distribute that 2. So 2 pi minus 2 theta. Then we'll use our difference formula. So I've got 3 times cosine 2 pi cosine 2 theta plus sine 2 pi sine 2 theta. So this whole thing is going to be 0. Cosine of 2 pi is 1, so this is going to simplify to 3 cosine 2 theta. So it's got theta equals pi over 2 symmetry. And let's check for symmetry with respect to the pole. So now we're going to replace our theta with cosine 2 pi plus theta. So we have 3 cosine 2 pi plus 2 theta. Again, we'll go ahead and use the sum formula for cosine. So I have cosine 2 pi cosine 2 theta minus sine of 2 pi sine of 2 theta. Again, this will be 0 because the sine of 2 pi is 0, cosine of 2 pi is 1, and this is going to simplify to 3 cosine 2 theta. So we see it has all 3 types of symmetry. And again, we know it's going to look like a rose since it has all kinds of symmetry. I'm going to start by just graphing some points from 0 to pi over 2, because any points that I graph, we know we can reflect them over the polar axis, we can reflect them over theta equals pi over 2, we can rotate them 180 degrees because it has all types of symmetry. So starting with 0, I've got 3 cosine of 2 times 0. So 2 times 0 is 0, the cosine at 0 is 1, so 3 times 1 is 3. So this is going to be 3 comma 0, so that's going to be right over here. And then let's do pi over 6. So I have 3 cosine 2 times pi over 6 is going to be pi over 3. And the cosine of pi over 3 is a half times 3 is 3 halves. So that's 3/2 comma pi over 6. So we're going to go about 1.5 and rotate to pi over 6 right there. Alright, so at this point, I can reflect it over both axes. So I'm going to reflect it down here. And I'm going to reflect it over theta equals pi over 2 to right there. I'm going to try. There we go. Okay. All right. Let's move on to pi over 4. Actually, we could also rotate this 180 degrees. So I'm going to rotate it 180 degrees to 7 pi over 6. All right. So for pi over 4, we have 3 cosine, and 2 times pi over 4 is going to be pi over 2. Cosine of pi over 2 is 0, so 3 times 0 is 0. So that's 0 pi over 4. So this just gives us a point at the origin. And then let's do pi over 3. So I have 3 cosine 2 times pi over 3, so that's 2 pi over 3. Cosine of 2 pi over 3 is going to be negative 1/2. So negative 1/2 times 3, so that's negative 3/2. So that's negative 3/2 comma pi over 3. So negative 3/2 and rotating pi over 3, that's going to put me right over here. And again, we can reflect this point. So let's reflect it over to here. There we go. And then I'm going to reflect it over the other axis over there, and I'm going to rotate it 180 degrees over to there. All right, so continuing on to pi over 2, I have 3 cosine 2 times pi over 2 is pi. Cosine of pi is negative 1, so that's negative 3. So I have negative 3 pi over 2. So 1, 2, 3, and then I'll rotate pi over 2, puts me there. So it's also going to be at 1, 2, 3 over to there. And oh, I forgot to reflect this point over here at 3 over to there. So knowing that this is a rose and having these points, we should have enough to kind of sketch in a curve. So it should look something like this. And then back up to here. And there you have it. All right, so again, once you know what the shape is and you know what kind of symmetry it has, it makes it a lot easier to graph these. As always, make sure you get any of your questions answered, and we'll see you next time.